Hello everyone. Today we'll study some probability distributions. Let me introduce the first one, called discrete uniform distribution. The first one is called discrete uniform distribution. Let Sn be a set of n real numbers. So Sn equal to S1, S2, X3 up to Xn. Let Sn be a set of n real numbers. That's the first one, second one, third one, and that's the n one. Assume the chance of choosing each number is the same. Assume the chance of choosing each number from the set is the same. When a number in a set is randomly chosen, let the random variable x represent the value of the chosen number. Then this random variable x has a uniform distribution, has a discrete uniform distribution. Has a discrete uniform distribution. And the probability function of x is f of x equal to what? What's the probability function? In a set, there are n elements, there are n numbers. We don't only choose a number from the set. So the chance of getting each number is 1 over n. Since every number has the same chance to be chosen, the chance of getting each number is 1 over n. Number of variable outcome divided by number of all possible outcome. Probability is always number of variable outcome divided by number of all possible outcome. So f of x is 1 over n for all x in the set. the chance of getting each number is 1 over n for all x in the set. So the support of x is what? What's the support of x? Support of x represents a set of all possible x values. Support of x represents a set of all possible x values. Since x represents a number, the value of the total number. Since x represents the value of the total number, we may choose s1. So x could be s1. We may choose s2. So s could be s2. We may choose x3. So s could be s3. S could be any values in a set. S could be any values in the set, which is the same as Sn. S could be any values in the set, which is the set Sn. So the set Sn is support of x. Since here x has discrete uniform distribution, so the notation for x here, the notation for this random variable x is uniform distribution Sn of Sn. That's the notation for this random variable x. Next, let's look at an example. Let S be the set -3, -1, 2, 4. When a number is randomly chosen from the set, let the random variable x represent the value of the total number. Find each of the following probabilities. Part A, probability that s equal to -1. Part B, probability that x less or equal to 0. Part C, probability that s is greater than 0. First step, write down the distribution for x first. Write down the probability distribution for x first. Here, this x is uniform, discrete uniform distribution. Write down the probability distribution for x first. Here, x is uniform distribution over the set S. Here, S is the uniform distribution over the set S. Probability function for x. Probability function for x is 1 over 4. Since here in the set there are 4 numbers. Probability function is, in general, is 1 over n. When there are n elements, probability function is 1 over n. Here is 1 over 4, since there are 4 elements. For all x in the set. And what's the support of x? S could be any chosen value, could be -3, -1, 2, and 4. Support of x is -3, -1, 2, and 4. So that's all we need to write down first. the probability distribution, probability function, and support of x. Then based on this, answer the question. First question, what's probability that s equal to -1? Probability that s equal to -1 is the same as f of -1. Since -1 belongs to the set, the chance of getting -1 is 1/4. For all x in the set, the probability is 1/4. Part B. What's the probability that x less or equal to 0? What's the probability that s less or equal to 0? When s is less than or equal to 0, it could be -3 or -1. So it could be f of -3 plus f of -1. When s is less or equal to 0, s could be -3 or -1. So that's f of -3 plus f of -1. F of -3 is 1/4. F of -1 is also 1/4. For all x in a set, probability is 1/4. That's a half. Part C. What's the probability that s greater than 0? If s is greater than 0, it could be either 2 or 4. That's f of 2 plus f of 4. For all x in a set, its probability is 1/4. 1/4 plus 1/4 is 1/2. Next example. Let S be a set from 1, 2, 3 to 100. When a number is randomly chosen, when number is randomly chosen from the set, let the random variable x represent the value of the chosen number. Find each of the following probabilities. Find each of the following probabilities. Part A, probability that s equal to 10. Part B, probability that s equal to 50. Part C, probability that s is less than 20, less than or equal to 20. Part D, probability that s is greater or equal to 40. So first step, write down the probability distribution first. Write down the probability distribution first. Here, x is a uniform distribution over the set S. Here, x is the uniform distribution over the set S. Since we are randomly chosen a number, we randomly choose a number here. Every number has the same chance to be chosen. X is a uniform distribution over the set S. Next, write down the probability function. For discrete uniform distribution, the probability function is 1 over n. N represents the number of elements in the set. Here, from 1 to 100, there are 100 elements in the set. So f of x is 1 over 100. For all x in the set, here x in the set is 1, 2, 3, 4, 5, up to 100. For x equal to 1, 2, 3, up to 100. And what's the support of x? Since we randomly choose a number from the set, every number in the set could be chosen. So the support of x is the numbers 1, 2, 3, up to 100. Since x represents the value of the total number, and every number could be chosen, every number could be chosen. Since every number could be chosen, support of x is every number in the set. Now let's answer the question. Always write down these three information first. Probability distribution, probability function, and a support. Then answer the question. What's the probability s equal to 10? Probability s equal to 10 is f of 10. 10 is one of these numbers. 10 is one of these numbers. So the probability of 10 is 1 over 100. Part B. What's the probability s equal to 50? Probability that s equal to 50 is f of 50. Since 50 is one of these numbers, f of 50 is 100. It's 1 over 100. Part C. Probability that x is less or equal to 20. Here, if x is less or equal to 20, x could be 1, 2, 3, up to 20. From f of 1 to f of 20, every number is between 1 and 100, so their probability is 1 over 100. For each of them, probability is 1 over 100. For each of them, the probability is 1 over 100, because every number here, 1, 2, 3, up to 20, they all between 1 and 100. So probability for each of them is 1 over 100. Then add them up. From 1 to 20, there are 20 terms. 1 over 100 plus itself 20 times, that's 20 over 100. Which is 1/5. Part D. What's the probability that s is greater than or equal to 40? That means x could be 40, 41, up to 100. Suppose from 1 to 100. If s is greater than 40, that means it's from 40 to 100. And for all its x, the probability is 1 over 100. For all its values, the probability is 1 over 100, because f of x is 1 over 100. How many terms do we have? From 40 to 100, how many terms do we have? We know from 41 to 50, there are 10 numbers. 51 to 60, there are 10 numbers. From 91 to 100, there are 10 numbers. So from 41 to 100, from 41 to 100, there are 60 numbers. And if I include 40, it will be 61 numbers here. From 40 to 100, there are 61 numbers. From 40 to 100, there are 61 numbers. Since there are 61 numbers, it should be 61 terms here. It should be 61 terms here. 1 plus 100, 1 over 100 plus itself. If there are 61 terms, that's 61 over 100. Next, let me introduce another probability distribution called Bernoulli distribution. Consider a set which has only 2 elements. Which contains only 2 elements. Success and failure. Consider a set that contains only 2 elements, success and failure. Assume the chance of choosing success is p. This is lowercase p. Then the London variable x when an element is randomly chosen from the set. Let the London variable x assign success to 1. And failure to 0. Let x assign success to 1, failure to 0. Then this random variable, we say this random variable x this random variable x has a Bernoulli distribution. And what's the probability function of x? Is what? What's the probability function of x? What's the probability function of x? We know that the chance of getting 1, the chance that s equal to 1, probability that s equal to 1 means we get success because s assigns success to 1. The chance of getting s equal to 1, the chance that s equal to 1, that means it's the chance of getting success, which is p. The chance that s is 0, the chance that s is 0, that means we get a failure because s assigns failure to 0. Probability that s equal to 0 is the probability of getting failure. Probability of getting failure is probability of not getting success, which is 1 minus p. There's only 2 elements. If we get success, means we don't get failure. If we get failure, means we don't get success. So the chance of getting 0 is the chance of getting failure. The chance of getting failure means is the chance of that we don't get success, which is 1 minus p. So s has only 2 values. Probability that s equal to 1 is p. Probability that s equal to 1 is the probability of getting success. Probability s equal to 1 is the probability of getting success. Probability of s equal to 0 is the probability of getting failure. Getting failure is the chance that we don't get success, which is 1 minus p. So from here we can tell that f of 1 is p. F of 0 is 1 minus p. F of 1 is p. F of 0 is 1 minus p. So f of s can be written as p if s equal to 1. One minus p if s equal to 0. So f of x is p if s equal to 1. It's 1 minus p if s equal to 0. That's the probability function. How about the support? What's the support here? Since s has only 2 possible values, 0 and 1, since s has only 2 possible values, 0 and 1, support of x is only 0 and 1. Since s has only 2 possible values, 0 and 1, support of x is 0 and 1. Since this random variable of x here has a Bernoulli distribution, so the notation for x is a Bernoulli distribution where the chance of getting success is p. That's the notation for this random variable x. Now let's look at an example. Let x be a Bernoulli distribution where the chance of getting success is 1 over 3. Find probability that s equal to 0 and probability that s equal to 1. So first step, write down the probability functions first. Write down the probability function and the support first. F of x is p if s equal to 1. 1 minus p. 1 minus p, this number represents p. F of s is p if s equal to 1. And it's 1 minus p if s equal to 0. 1 minus p here is 2/3. if s equal to 0. That's the probability function. And support of x, for Bernoulli distribution, support of x is always 0 and 1. Now answer the question. Probability that s equal to 0 is f of 0. f of 0 is 2/3. Probability that s equal to 1 is f of 1. f of 1 is 1/3. Next example. Let x be the Bernoulli distribution. Where the chance of getting success is p, is 0.7. Find probability that s equal to 0 and probability that s equal to 1. So first step, let's write down the probability function. F of x is p if s equal to 1. 1 minus p if s equal to 0. Here p is 0.7. Here p is 0.7. Here p is 0.7. So the probability function f of x is 0.7 if s equal to 1. 1 minus 0.7 is 0.3 if s equal to 0. Support of x, for Bernoulli distribution, support of x is always 0 and 1, is always 0 and 1. So probability that s equal to 0 is f of 0. When s is 0, the probability is f. When s is 0, f of 0 is 0.3. Probability that s equal to 1, that's f of 1. When s equal to 1, f of 1 is 0.7. Next, let me introduce binomial distribution. Consider a set S that has only two elements, success and failures. Consider a set S that has only two elements, success and failure. Assume the chance of getting success is p. Assume the chance of getting success is p. When we randomly choose an element from the set S, S, n times. When we randomly choose an element from S n times, with replacement, Means we choose the element and put it back. Choose it again. Let the random variable x represent the number of chosen success. The x represents the number of chosen success. Then this random variable x has a binomial distribution. The probability function of x is what? How do we want a probability function of x? When we're choosing an element from the set n times, every time we are either getting success or failure. We choose an element from the set n times. Every time we are either getting success or failure. Every time we are either getting failures or success. Assuming we are getting x success, we have success x times. So we are getting success x times. S could be in any place. S could be in any place here. Since we are getting x success, we have x success over a total of n choices, over a total of n elements. So S could be in any places. We first of all choose x place. We first of all choose the position for x. We pick position for success first. The number of ways of choosing x position from n position is n choose x. The number of ways of choosing x position out of n position is n choose x. And then for those positions, we have x layer. Then the chance of getting success is p. We are getting success x times. The chance of getting failure is 1 minus p. Every time if we don't get success, we get failure. So it's an opposite. The chance of getting failure is 1 minus p. And we are getting failures. We are getting failures m minus x times. We are getting failures m minus x times. Here x could be 0, we make it 0 success, 1 success, 2 success, at most n success. We make it 0 success, 1 success, 2 success, at most n success. So the support of x, all possible value for x is 0, 1, 2, 3 up to n. the notation for this probability function, the notation for this random variable x is this x is binomial distribution there are two parameters n and p. Binomial distribution has two parameters n and p. N represents the total number of trials. We are choosing an element from the set n times. N represents the total number of trials. P represents the chance of getting success for each trial. So in this formula, N represents the total number of trials. P represents the chance of getting success for each trial. P represents the chance of getting success for each trials. X represents number of chosen, the number of success. X represents number of success. Here, X is a random variable represents the number of chosen success. So n is the number of total trials. We choose an element from the set n times. P is the chance of getting success on each trial. X is number of success, number of chosen success. X is number of chosen success. Now let's look at example. Let X be the binomial distribution with two parameters. (12 and 1/3). Find each of the following probabilities. Probability S is equal to 4. Probability S is equal to 7. Probability S less or equal to 2. Probability S greater or equal to 2. First step, write down the probability function first. This formula is called probability, is the probability function. Write down the probability function first. Here n is 12. In this number here, first number represents n. For this notation, first number represents n, second number represents p. Here n is 12. P is 1/3. So using the formula, The probability function is 12 choose x times 1/3 to the power of x. 1 minus p is 1 minus 1/3, which is 2/3, to the power of n minus x. N is 12. N is 12. N is 12, so that's 12 minus x. This is a probability function. X varies from 0 to 12. Okay, or we can write it here. Support of x is from 0, 1, 2 to 12. Now, based on this information here, answer the question. First question, what's the probability x equal to 4? Probability that x equal to 4 is f of 4. For f of 4, we plug in 4 for x. That's 12 choose 4 times 1/3 to the power of 4 times 2/3 to the power of 12 minus 4 is 8. Then use calculator for the answer. Part B, what's the probability that x equal to 7? Probability that x equal to 7 is f of 7. F of 7, we plug in 7 into the function. Plug in 7 for x. 12 choose 7. 1/3 to the power of 7. 2/3 to the power of 12 minus 7 is 5. Then use calculator for the answer. Part C, what's the probability that x less or equal to 2? Probability that x less than or equal to 2, x could be 0, 1, or 2. That's f of 0 plus f of 1 plus f of 2. For f of 0, we plug in 0 for each x. That's 12 choose 0 times 1/3 to the power of 0. 2/3 to the power of 12 minus 0 is 12. F of 1, we plug in 1 for x. That's 12 choose 1. 1/3 to the power of 1. 2/3 to the power of 12 minus 1 is 11. What's f of 2? We plug in 2 for x. That's 12 choose 2. 1/3 to the power of 2. 2/3 to the power of 12 minus 2 is 10. Then use calculator for the rest. Part D, what's the probability that s greater or equal to 2? If s is greater or equal to 2, s could be 2, 3, 4, 5 until 12. There may be too many terms. If we find x equal 2, 3, 4, 5 up to 12, there may be too many terms. It may take too much time. A simpler way is think of the complement. Probability of x greater or equal to 2, the complement is x less than 2. For s greater than or equal to 2, the complement is x less than 2. If x is less than 2, s could be either 0 or 1. So that's f of 0, f of 1. F of 0 is 12 choose 0 times 1/3 to the power of 0 times 2/3 to the power of 12 minus 0 is 12. F of 1, we plug in 1 for x. That's 12 choose 1. 1/3 to the power of 1. 2/3 to the power of 11. Then use calculator for the rest. Next example. When a coin is tossed 20 times, find each of the following probabilities. when a coin is tossed 20 times, find each of the following probabilities. Part A. What's the probability of getting exactly 10 heads? Part B. What's the probability of getting at most 3 heads? Part C. What's the probability of getting at least 3 heads? So first of all, let's write down the probability distribution first. So let's set out the problem first. Let the random variable x represent the number of heads the x represents number of obtained heads. Then here x has a binomial distribution. For every trial, we are either getting heads or tails. Consider heads is success, tail is failure, and we are tossing a coin 20 times. Means we have 20 different trials. We have 20 trials, and consider head represents success, tail represents failure. This is a binomial distribution. X is a binomial distribution. Here, where n is 20, because we are tossing 20 coins, we're tossing a coin 20 times. That means 20 trials. What's P? P represents the chance of getting success for every trial, for each trial. P represents the chance of getting success for each trial. Here, for each trial, the chance of getting head is a half. For each trial, the chance of getting head is a half. So here, P is a half. Next, write down the probability function. The formula for probability function is n choose x. Here n is 20, so 20 choose x. P to the power x, here P is half. P is half, so half to the power x. The formula is P to the power x. Here P is half, so plug in half for P. Then next, 1 minus P. 1 minus P to the n minus x. P is half. 1 minus P is 1 minus half, which is half. M minus x. N is 20. When we flip 20 coins, we may get 0, 1, 2, 3, up to at most 20 coins, 20 heads. So the support of x is the set 0, 1, 2, up to 20. It's support of x, the set of all possible the set of all possible values of x. Next, based on this, answer the question. Part A. What's the probability of getting exactly 10 heads? What's the probability that x equal to 10? X represents number of heads, number of obtained heads. So part A, we're looking for probability that x equal to 10, which is f of 10. We plug in 10 for x. Plug in 10 for x. That's 20 choose 10 times a half to the power of 10 times a half to the power of 20 minus 10 is another 10. Then use your calculator for the answer. Use your calculator for the answer. Part B. What's the probability of getting at most 3 heads? Part B. What's the probability of getting at most 3 heads? At most 3 heads means 3 or less. At most 3 heads means 3 or less. That's probability that x less or equal to 3. Suppose from 0 to 20. If x is less or equal to 3, x could be 0, 1, 2, 3. That's f of 0 plus f of 1 plus f of 2 plus f of 3. Then plug in f of 0, plug in 0 here. It's 20 choose 0 times half to the power of 0 times half to the power of 20 minus 0 is 20. That's f of 0. For f of 1, do the same thing. 20 choose 1. A half to the power of 1. A half to the power of 20 minus 1 is 19. Next, f of 2. 20 choose 2. A half to the power of 2. A half to the power of 20 minus 2 is 18. Next, 20 choose 3. When I plug in 3, I have 20 choose 3. Half to the power of 3. Half to the power of 20 minus 3 is 17. Then use your calculator for the answer. Use your calculator for the answer. Part C. What's the probability of getting at least 3 heads? What's the probability of getting at least 3 heads? At least 3 heads means 3 or more. Probability that s is greater than or equal to 3. At least 3 heads means 3 or more. Here, suppose from 0 to 20. If we consider s greater than 3, s could be 3, 4, 5, 6, 7, 8, 9, 10, up to 20. There are too many cases. So here we can think of the complement. Probability that s is greater than or equal to 30, greater than or equal to 3 is 1 minus probability that x is less than 3. When s is less than 3, we can consider s is 0, 1, or 2. When s is less than 3, we consider s is 0, 1, or 2. Then use your calculator. Plug in first, then use calculator. If I plug in 0, 1, and 2. If I plug in 0, I get 20 choose 0. Half to the power of 0. Half to the power of 20 minus 0 is 20. If I plug in 1, I get 20 choose 1. Half to the power of 1. Half to the power of 20 minus 1 is 19. Next is 20 choose 2. Half to the power of 2. Half to the power of 20 minus 2 is 18. Then, use your calculator for the rest. Next example. When a die is tossed 8 times, find each of the following probabilities. Part A. What's the probability of getting a number 5 3 times? Part A. What's the probability of getting number 5 3 times? So let's set out a problem first. Let x represent let the random variable x represent the number of obtained number 5. Let the random variable x represent the number of obtained 5. Then x is a binomial distribution. We consider getting 5 is a success. Any number other than 5 is failure. We consider getting a 5 is success. Getting anything else, anything other than 5 is a failure. And we do the experiment 8 times. That means we have 8 trials. So this is a binomial distribution. Here x is a binomial distribution. Where n is n. What's p? We consider getting a 5 is success. So the chance of getting success is 1 out of 6. When we roll a die, the chance of getting 5 is 1 out of 6. That's the chance of getting success for each trial. Next, write down the probability function and the support. The formula for binomial distribution is n choose x. Here n is a choose x. P to the power of x. P is 1 over 6. So 1 over 6 to the power of x. Times 1 minus p. P is 1 over 6. 1 minus p is 5 over 6. To the power of m minus x. N is a. Here x could be 0, 1, 2, at most a. When we roll a die 8 times, we can get number 5. 0 times, 1 times, 2 times, at most 8 times. So the support of x zero, 1, 2 up to a. Now answer the question. What's the probability of getting number 5 3 times? X represents the number of obtained 5. So probability of getting number 5 3 times. Plug in 3. A choose 3. 1 over 6 to the power of 3. 5 over 6 to the power of a minus 3. A minus 3 is 5. Then we can use calculator for the rest. Use calculator for the answer. Part B. What's the probability of getting a number? Less than 5. Four times. Part B. What's the probability of getting a number less than 5 4 times? So part B totally changed the problem. We have to set up the problem again. Part B totally changed the problem. Because for part A, the chance of we consider getting a 4 is success. For part B, we consider getting a number less than 4 is a success. The chance is different. For each trial, the chance of getting a 4 is 1 over 6. But the chance of getting a number less than 4 is not 1 over 6. It's not 1 over 6. Getting a number less than 5, it could be 1, 2, 3, 4, which is 4 out of 6 outcomes. So here, exchange the probabilities. We need to set our problem over. So let the random variable x represent the number of outcomes which are less than 5. The x represents number of outcomes which is less than 5. Then we consider a number less than 5 is success. A number greater than 5 is a failure. This is binomial distribution, and we are doing this experiment 8 times. We repeat the same experiment 8 times. This is a binomial distribution. We consider a number less than 5 is success, and a number greater than or equal to 5 is failure. So this is a binomial distribution. X is a binomial distribution, where n is a. Since we have a trials, we toss a coin, we toss a die 8 times. So n is a. What's the chance of getting success? What's the chance of success for each trial? We consider getting a number less than 5 is a success. Getting a number less than 5 could be 1, 2, 3, 4. So that's 4 outcomes out of total of 6, which is 4 over 6. 4 over 6 can be reduced as 2 over 3. 4 over 6 can be reduced as 2 over 3. Next, write down the formulas. The formula for probability distribution is n choose x, here n is a choose x, times p to the power of x, here p is 2/3, so it's 2/3 to the power of x, times 1 minus p, 1 minus p is 1/3, to the power of m minus x, n is a, so you get a minus x. This is a probability function, and x, the number of success could be 0, 1, 2 up to a, since we have a trials. So support of x is a set 0, 1, 2 up to a. What we are looking for is getting a number less than 5, 4 times. We are looking for probability that s equal to 4, which is f of 4. We plug in 4 for x. That's a over 4, a choose 4 times 2/3 to the power of 4 times 1/3 to the power of a minus 4 is 4. Then use calculator for the answer.